All right, well, thank you all the panelists for joining, and thanks attendees for coming today. We'll have a recording of this sent out to anyone that registered as well. I'm Lynda. I'm a fifth-year PhD student at Emory University, and I'm also one of the current Ecological Forecasting Initiative Student Association co-chairs. And we wanted today to have a panel that's dedicated towards understanding how forecasting can be used, or other kinds of predictive ecological modeling beyond just careers in academia. And so today I'm going to have each of the panelists introduce themselves. So I think we should go in order of like alphabetical surname. So Tina, if you want to start, and let me put here in the chat the things that would be good to have in your intro. Okay. So name, pronouns, current position, what you're doing, what you studied in graduate school, and how you use forecasting or modeling in your current position.
Great. Yeah. So my name is Tina, and my pronouns are she, her. I am the director of white nose syndrome research at Bat Conservation International, but I'm really just a research scientist. I studied white nose syndrome in grad school, disease ecology, more broadly as the genre. White nose syndrome is a disease in hibernating bats, which is a huge conservation concern for several species. So while I do a lot of ecological research, it's very applied. So it's all related to the conservation of these white nose syndrome affected species. And the modeling that I do is a lot of population modeling. We work very closely with a lot of federal agencies, including the North American Bat Monitoring Program, where we're just really trying to understand what are population trends over time and how is white nose syndrome impacting different species and populations. And we also do a lot of basic research related to conservation solutions, testing different strategies and developing different tools that we might be able to use to help bats. Yeah, and that's me.
Awesome, thanks. Let's see, Laura, do you want to go next?
Sure. Hi, everyone. My name is Laura Diacundo. My pronouns are they, them. My current position, I am an ecologist at the US Geological Survey. I'm stationed at the Wetland and Aquatic Research Center, which is in Gainesville, Florida. In grad school, I actually studied bats too. So I was a bat biologist in a former life and did some distribution modeling in my master's degree. And then in my PhD, I did some modeling of looking at the impacts of forest management on the endangered Indiana bat. Now, however, I work in the Everglades. So I work on Everglades restoration, and what I do is I develop species distribution models and forecasting models to look at how changes in the management of the hydrology of the Everglades system is going to impact the wildlife species that exist in the Everglades. And so I work a lot with other federal partners, tribal partners, university partners to coordinate how we're going to get the water right in the Everglades.
Awesome, thanks, Laura. Alex, I believe you're next.
All right, hi, I'm Alex, pronouns she, her, and I am currently a research oceanographer with the Harmful Algal Bloom Forecasting Branch in NOAA's National Centers for Coastal Ocean Science. And we do a lot of harmful algal bloom modeling and forecasting, as our name suggests. So use models to kind of figure out how blooms will occur, their intensity, and kind of their impacts on the ecosystem as well as humans. For graduate school, I tangentially did, I guess, have research, but was more focused on kind of organic matter cycling in estuarine and coastal systems. So thinking about organic nitrogen and how different phytoplankton species, including some HABs, might use that as a nutrient source. So yeah, in my current position, kind of as folks mentioned, I work with a variety of partners, including stakeholders who kind of use our models and our forecasts to make management decisions, but also with academic partners and a whole host of state and county and federal partners as well. So excited to be here.
Thanks so much. Giovanni?
Hi, everybody. I believe, yeah, hi, everybody. Sorry, can you hear me okay? All right, I was having microphone issues earlier. Thanks so much for having me. This is super exciting. My name is Rapacciuolo, and I'm Director of Applied Data Science at NatureServe. NatureServe is an NGO based out of DC. It basically it's a network of organizations that collect and integrate data on the most imperiled species in North America, or we should say US and Canada. And so just briefly on what I do, since I'm talking about it, I have the pleasure of being able to play around with this amazing data set of really, really cool field data on the most imperiled species. And in grad school, I basically tested how well species distribution models transferred over time, so they could actually forecast potential changes in species ranges that might occur. And these days, I use the data from the NatureServe network to build the whole species distribution modeling program, where we actually use the data that we have to try and predict where these very restricted species and sometimes undersampled species are likely to be around the landscape, and working towards also integrating climate change effects. So really excited to be here, and thank you for having me.
Yeah, thanks. And then Christy.
Hey, I'm Christy Rollinson. I am the forest ecologist at the Morton Arboretum. So we are, excuse me, an independent private botanic garden out in the suburbs of Chicago. And so I'm a research scientist there, one of about a half dozen of us that specialize in different things. I'm a jack of all trades. In graduate school, I actually didn't do any modeling. I actually haven't had math since high school. So I figured it out as I go along. My master's was doing kind of community ecology and phenology with a warming experiment. My PhD was tree ring based and kind of comparing patterns of interspecific growth along climate gradients. And I use it in a bunch of different ways here. A lot of my work spans both kind of basic and foundational science as well as applied. So the modeling is kind of in both ends. So doing some phenology modeling, honestly, kind of as an engagement thing, since everybody wants to know when the leaves are going to change color or spring is going to finally arrive. But also do some assisting with kind of climate envelope and niche modeling for threat detection, as well as helping strategize where species should be conserved in botanic gardens. And then we've got a new project I'm really excited about where we are improving drought early warning and mitigation forecasting for cities, since that's a big black box for our state climatologist. So a bit of everything, figure it out as they go along.
Thanks, Christy. Juniper?
Yeah, morning, everybody, or good afternoon, I guess, if you're over on the East Coast. Juniper Simonis, I use they, them pronouns. I'm out in Portland, Oregon, and my current position is as owner and lead scientist of DAPPER Stats, a company I founded going on 7.5 years ago now. And in grad school, I studied spatial food web and population dynamics out on Appledore Island in the coastal Gulf of Maine, looking at how movement of predatory insects synchronizes lower trophic dynamics. But in time since then, I've really stepped out of academia and into really working with kind of on the ground managers of populations and various ecosystems. I do a lot of consulting kind of across the institutional range. So I work with governments sort of across the spectrum, tribal, federal, state, and local, NGOs, other academics, etc. And I'm also often the like the quantitative person, or the like really stats or computationally heavy person on a job. And right now, that typically involves a lot of forecasting and basically building out different kinds of computational infrastructures that allow kind of the scaling up and the repeatability of forecasting models so that we can spend more time doing the science and less time writing the code again and again and again kind of thing. So, yeah.
Thanks. And then last but not least, Jake.
Hi. Thanks for having me. I'm Jake Zwart, use he, him pronouns. I'm based in San Francisco, California, and I'm currently the acting data science branch chief of the water mission area in the US Geological Survey. In graduate school, I guess I started off as like a field ecologist studying lake hydrology and how carbon cycling is impacted by different hydrologic characteristics in lakes. And then towards the end of grad school, I kind of moved more towards more away from field ecologist and more towards modeling of lake hydrology and carbon cycling. And that got me into the US Geological Survey, did a postdoc at the USGS, still in my current branch of the data science branch. And I will say, I thought I had a lot of good modeling experience in grad school, but then when I got to the data science branch, it felt like I was going back to first year of grad school because I was with all these people that knew way more than me. It was really intimidating. And I was like, oh my gosh, I don't know anything about coding. But, luckily everybody was very kind and friendly and taught me a lot of skills that I still use today. And I learned a lot along the way. In my current position in the data science branch, well, not as the acting data science branch chief, but in my other job, I would do mostly forecasting work. So I'm a forecast coordinator for the water mission area. I work on harmful algal bloom forecasts in streams, forecasting stream temperature, and then also forecasting stream flow drought predictions. And then in my position as the acting data science branch chief, I kind of oversee a bunch of different projects that our staff are doing, and that spans from working on research pipelines. So how do we efficiently move data into making model predictions or data analyses, data visualizations, which are more of a, I guess, externally facing presence that our data science branch has. So mostly distilling water information to digestible nuggets for the public. A bunch of different modeling activities, which include forecasting, but also hindcasting and projections. And also some analytics work, which is more focused on, how many people and what types of people are using our products, and how can we better make these products based on the analytics that we're collecting. And I'll stop there.
Thanks everyone for the intros. So the way that we're gonna do the panel today is we had about 8-ish questions that were submitted by some of the registrants for what they wanted to talk about. For those of you that are currently attending, there's a Q&A button at the bottom. Feel free to start posting any questions that you already have or that you want answered. And we'll answer them as we go. And when there isn't questions that are like open in the chat, we'll just go over the ones that were previously sent in. So the four kind of broad categories that were sent in before were like bigger picture career decision making, like how did you choose to go away from academia into your current position, kind of networking and more of nitty gritty of how you actually got your job, and then what your daily life looks like, and then also like skill development to be in the position that you are now. So I think that I'll just let you all answer as you're moved to. I think that we should be able to manage talking that way. So the first question was, were you ever at a crossroads between deciding between academia and whatever your current position is? Like, what pros and cons did you weigh most heavily in your decision making?
I'll go because I think sometimes I might be an outlier. I was never interested in academia, so non-academic was plan A for me. Academia is just not my vibe. I won't go on my rants about it, but I got into science because I wanted to do conservation and specifically forest conservation and use science to do that. So, you know, academia was kind of my backup plan that thankfully I didn't have to go to. But I also like that in my job, I can use my science to actually help advocate. I think sometimes there's this idea that scientists have to be neutral and like careful about trading opinions. And like some positions, that's definitely more true than others. But working for a mission-driven organization whose mission I'm wholeheartedly behind, you know, yay trees, I'm able to use my science so that we're making science-backed decisions and sound decisions, but using it to advocate for things that I feel strongly about are important. So academia, not my thing.
Yeah, I feel like we often pit academic careers as like the first go, which I mean, I'm sure many of us here were not interested as academia as our first career as well. So I think that resonates. Does anyone else have any?
I guess, I don't know if I have much to add to Christy's, but my answer was no, I was never interested in academia. But I can give a different, maybe a little bit different perspective. I guess I had a lot of, I guess, internal values or something of like science being a public good, and government science was like maybe the closest that I could come to that ideal, even though it's not perfect. So I did have like, you know, I was pretty sure I wasn't going to go or wanted to go into academia, but I was weighing different options between non-academic things. So, you know, government sector or NGO or even private industry and some of these, you know, other environmental data science organizations. So those were definitely on my mind. And, you know, luckily there's an open position at data science branch that I was working at. So I stuck with government.
I can go the opposite side. Not that I'm like yay academia or was ever like super yay academia, but I figured that was kind of what the trajectory that I was on, and I was like, oh, I like science, I'm gonna be a professor, I guess. But that's sort of the trajectory that I feel like a lot of students end up getting put on because a lot of faculty are academics by only training, and so that's sort of how they prepare a lot of folks for the real world. And it was, you know, sometime about halfway through grad school when I was like really in the thick of, you know, writing grants for my stuff. Cornell's very laissez-faire, and so I was basically a little mini faculty member, and I was like, oh, okay, I get it. Maybe I don't want to do this. And that's when I really started kind of looking at other options. And, you know, I'm not, still not like completely turned off from academia. In fact, I think because of the problems of sort of training history things, I think there's actually a need for folks who leave academia to go back to academia and help train people. If folks are interested, I think, there's a lot to be gained by practitioners going back and teaching and working with students more directly. But yeah, I, like to keep all of my options on the table. And that's one of the nice things about contracting is that I do get to work with folks that really kind of run that gamut. And, I work with grad students a lot, as well as, folks who never had a biology class past high school. And so it really focuses my translational abilities a lot. And I think that's really helpful. But yeah, I think there's a lot of different pathways. And I would definitely encourage anyone who's interested in careers outside of academia to reach out to any of us or anybody else that you know for coffee date kind of things. Ask, whatever kind of questions you're interested in, and really kind of pick somebody's brain, because you might not necessarily have opportunities in your day-to-day life to get some of the those kind of pressing questions that you might have about work-life balance or topics of research or whatever is interesting to you in particular. So yeah, I would say reach out of your immediate contacts if you're thinking about going down a non-academic route.
I'll add on to what Juniper was saying, that at the tail end of my PhD, I was expressly interested in leaving academics specifically to learn outside of academics, but always with the intention of coming back to it to bridge that gap. Because I felt like academics is always a little bit like one step behind where industry is in terms of the latest technology, development, etc. I'll also say that I think there's different degrees of academics. It's not just like one lifestyle or one career. I had done a master's before my PhD at San Francisco State University, and the culture of academics there was completely different than Berkeley, where I did my undergrad, or UC Santa Cruz, where I did my PhD. Those were both R1 universities where like your job is your life. And there's a lot of pressure to work your tail off and publish like crazy. And I think that's the type of academics that I was never attracted to. But I did know that there are lots of different types of universities out there that support different objectives, and ones that have a little bit more balance with like teaching and mentorship, which I love. I love teaching and mentoring students. And that's something that I would like to do again in my life at some point. So I didn't know if I was going to go to academics or outside of it. I saw pros and cons with both, pathways. But I do love where I'm at right now, and we do collaborate with a lot of researchers, and my job actually is very similar to what I was doing in my PhD, just with a little bit more applied research than theoretical. That's often the case in an academic place. I will say that the other thing that really moved me away from pursuing an academic job is, I'm a first generation Chinese American. I grew up in Los Angeles, California, and I've always felt comfortable in kind of larger cities and places that are really diverse. And I'll just be completely honest, I was very scared to move somewhere where I didn't, I wasn't familiar with the city, wasn't familiar with, whether or not the Chinese grocery store is going to be around the corner. And I saw a lot of my other colleagues having to move to the middle of nowhere, move to places that I wasn't sure that I would feel comfortable. So that drove a very large part of my decision-making in moving towards a different career path. yeah.
Yeah, I just to echo Tina, I think something that's not talked a lot about is, location and those other factors that go into making a job decision. I kind of agree that I wasn't necessarily going into non-academia, a non-academic job. It just kind of came at the right time in the right place. And for me, location was really important. So I was applying to all kinds of positions, kind of in the Mid-Atlantic region. And this just happened to be kind of the first job that stuck, that meet kind of the location requirements and the job duty requirements. I knew I really wanted to stay involved in research, and that hit that, and wanted to do some type of applied research. And so it was kind of the right time in the right place, and just, yeah, it felt like the right decision at the time. And I'm totally happy.
I can speak a little bit. I agree with everyone else. But I guess I was probably looking for an academic postdoc, and I even had one that really wanted me. And then the position that I'm in now popped up actually first as a contractor. So I started out as a contractor for the USGS and then was hired on as a Fed later on. But the advertisement for this job just really piqued my interest. I wasn't really interested in moving to Florida, didn't really want to go there. But the job just looked so cool. And so I took a chance on it, and I am really happy that I did. Another reason that I took it was because the salary was about double what I would have gotten as an academic postdoc. And so that also was a factor.
Yeah, I share a lot of what's been talked about already. I definitely weighed both options. What I was gonna say is I feel like I was very passive for a while. Like I sort of just rolled on to the next thing. I was doing a master's, and I was like, what's the next thing? I'm gonna do a PhD. And then I rolled on to a postdoc, and I was lucky enough to be able to do that without seriously having to weigh my options. But I guess the first time I really sat down and thought about it, then I started considering other options. So I would say, be active in your pursuit of what you want and, the criteria that you're following. And the other thing I was going to say is, to me, it's not such a black and white situation. It's not you're in academia or you're not. There are a lot of positions at the boundary between different institutions. And, oftentimes there's transitional kinds of positions for institutions that are sort of, a heavy research institute outside of academia that collaborates with a lot of industry or a lot of NGOs. Those are the kind of postdocs, and a lot of those are postdocs or other types of relatively junior positions that can be really useful to find out exactly, which aspects of your day-to-day work you like. So I would think about those kind of positions to put yourself in a situation that might tell you more about what you really like.
Did anyone else want to add on to that question?
I'll just say that's absolutely true. My supervisor, who's the chief scientist at Bat Conservation International, is also adjunct faculty at University of California, Santa Cruz. So there's, a lot of in-between spaces.
Yeah, and we'll get into, I think, more of like the pockets of what each of you are talking about too, because there's a lot of good nuggets to expand on there. One of the attendees has a question, and for those at the recording, I'm not sure if you can actually see it. So Whitney asks, how do you maintain your collaborations with academics? And I'll also tack on to that, why is that important? Or if that's important to you.
So I do work closely with academics still pretty often. I've served on master's students committees and have worked with graduate students and professors on different parts of projects that we're doing. I'll also say that ecologists at USGS are also allowed to be adjunct faculty at universities if they want to be. So you can maintain your connections to academia pretty easily. And there's also something called co-op units at USGS where you're actually a faculty member at a university and a USGS employee at the same time. And so those are options as well. There's not very many of them that exist in the country, but I know a bunch of them have been hiring lately. So there's ways to bridge the gap of being a federal scientist and an academic if you want both worlds too.
I can go sticking with USGS. We find our academic collaborations very valuable. And one of the reasons is why, at least in the water mission area, we often have like these larger multi-person projects and they have like some big mission that we're moving towards. And there isn't like a ton of, not a ton of room for exploration or experimentation, as opposed to, you know, academics, whereas that's a little bit more aligned with. And so we often collaborate with academics to do some of that experimentation and design for, you know, different modeling techniques, et cetera. And so we collaborate with a lot of computer scientist folks because really that's like the biggest need that we have in the water mission area right now. And there's different programs that are through USGS or elsewhere that you can funnel money from the government to fund grad students or postdocs. And so we've done that for many years, and that's a way that we, you know, have like very fruitful collaborations and, you know, improve our modeling that's geared towards water research. And so they do a lot of the development stuff for these new modeling techniques, and then we try to incorporate that back into our USGS work.
I'll circle back to what Laura said about adjunct. I don't have adjunct status at any university currently, but it's something about half or 3/4 of my colleagues do. In my experience, no university is going to say no to faculty they don't have to pay. So it's something that seems to not be too hard to get. And that allows my colleagues to take and be a primary mentor for grad students and different arrangements. Sometimes they teach there. We also have an arrangement where if we want to teach, we have ways through the Arboretum or through regional organizations where we can teach things that I haven't taken advantage of. But I do serve on committees, and not being affiliated with any one university, I end up serving on committees for, I think, up to 7 universities across the US. I like to think of it as I get to be the fun aunt and do all the easy parts of advising and mentoring. And then on the collaboration front, you know, I'm a research scientist. That's first and foremost my job. And so it's very similar to that part of being a tenure track professor where, you know, I'm writing grants, and the collaboration is essential because nobody can do it alone. And I think not even any one organization can do it alone. So in that instance, it's really kind of no difference than how science gets done in a university. It's just kind of the time balance and resource allocation.
We collaborate a lot with other academics and researchers, and it's essential actually to developing tools and solutions for white nose syndrome. You can imagine, like, as a small nonprofit organization, we don't have a lab or students to run small projects like testing a specific treatment or agents. So the best part that I really enjoy about working for a conservation nonprofit is the lack of territoriality that is inherent in a lot of research programs. Like, when you're an academic, like, that is your bread and butter. That's like what you make your career out of. And so there's so much territoriality with intellectual property. And, oh, I developed this, I put my name on this, this is, you know, my paper. Whereas where we're coming from, we're just working towards the same conservation goals. We want to make sure that we can figure out a solution or get to the next step. And so it's really the perfect collaboration because there's none of that need for ownership.
Does anyone else have comments for this question?
Sure, yeah. So I think, you know, to take a very logistical way of doing it, I, first of all, try not to burn bridges as much as possible. And so I stay in contact with a lot of folks that I was in grad school, and, even undergrad with, and, regularly get in contact with them. I still do some outreach with, stuff like this with panels in my undergrad for, career day panels and stuff. And, even just those like low level interactions keep you on people's radar and keep people on your radar. And similarly, like going to meetings, right? Like when I'm going to a science meeting, I'm going with particular things in mind. I'm often, have to do some kind of business development so that I can justify going for myself, right? So, I need to get some projects. And, I would say maybe like a quarter or so of the research that I do is funded through academic grants in one way or another. And so that kind of perpetuates itself to a good degree. And yeah, so, I think there's a lot of really kind of low level, just sort of like your own personal social network development that has definitely helped me maintain active collaborations with academics. And, one of the most ridiculous examples of kind of how important cold emailing can be is that like one of my major avenues of research in the last 7 years or so has been on impacts of renewable power on wildlife, and getting hooked into that research was the result of a failed postdoc job interview. The faculty advisor already had somebody who knew the particular model that they were going to be using, and it was basically lined up already, but she had to post the job out and everything, and we interviewed and hit it off, and she's like, I'm not going to be able to hire you for this, but I've got some other work that might be coming down the pike. And serendipitously she reached out to me at a time when I had some open time, and since then it's been a very fruitful collaboration and a lot of research and work coming my way. So I think a lot can spring from a very small and even failed interaction, and keeping options open can facilitate a lot of that kind of collaboration into future parts of your career.
I was just gonna just mention one thing here to give a slightly different perspective, which is, and it's slightly broader than this question, but it's about the interaction with academia and the room that we have to interact with academia. And I wanted to say that it can be difficult. So I'll say that in my current role, it's difficult to justify taking a lot of time to have in-depth collaborations with some aspects of academia, at least, because everything we do is essentially what you might think of as soft-funded. We're a relatively small nonprofit, so we have to justify every staff hour based on some project deliverable, essentially. And those project deliverables oftentimes do not intersect very well with academic research. So, the work it doesn't lend itself too much with interacting with academic research, which oftentimes is a lot more experimental or a lot more cutting edge. Whereas we work with, for example, federal agencies like the Bureau of Land Management, the Department of Defense, which need very firm results on tried and tested approaches, which are not in themselves very appealing from an academic point of view or from, you know, a research point of view. So to do it well probably takes going beyond your actual work hours, at least in my role. And so you can continue to do all the things that you might do as an academic, be on you know, editorial boards, in journals, you can go to scientific meetings, all this stuff, but oftentimes you might have to stretch what is your actual work hours, because some organizations won't necessarily recognize that as something that is useful for them. So I just wanted to put that perspective out, that it can be difficult to stay connected with academia in some roles, given funding constraints and job constraints. And the other thing, a very practical example is we don't have a library service. It's difficult for me to access research publications oftentimes. And that's the first step towards losing touch with, you know, cutting edge research sometimes. So.
Thanks for all those different perspectives. The next question is from Amy. She says, when you began your search for non-academic jobs after grad school, how long did it take you to find the job that you were excited about? If you didn't already have contacts or experience in collaborating with non-academic institutes, what approach did you take to find your position or create the opportunity that you were interested in? And this sort of also gets at one of the questions that was submitted more broadly of like, how did you get your job?
Yeah, so when my first postdoc actually, or my only postdoc, I worked at Linda Park Zoo in Chicago, and I got that job basically applying, you know, it was listed similarly to, it was like on Ecolog and those kinds of places, so fairly adjacent to you know, academic research, and so fairly well publicized in that kind of a space. And then when I moved out to Portland, I took started my own consulting company. I also took a job at a fisheries consulting company called Kramer, and you know, found that job through kind of typical job searching, you know, and I don't remember if it was Monster or Indeed or whichever one, but there are a lot of job sites that do a pretty good job at collating things, but they can be challenging to sift through. You know, kind of each job space has its own problems, whether you're talking about USA jobs being, so that's for all the government jobs, being kind of a ridiculous bureaucracy level of red tape kind of thing, or a lot of consulting jobs, which, you know, depending on what kind of work you want to do, the researchy, you know, ecosystem-y kind of environmental space, those jobs exist, but they're, you know, they're the needles in the haystack of business intelligence and healthcare forecasting and analysis, right? And so, you know, you might go on to one of those websites, or like on a collator like DICE or somebody like that, and find a whole lot of things, but most of them won't be, you know, the kind of research that, or kind of stuff that you might be interested in. And so there can be a lot of time spent kind of sifting through those things. And that's why I think one of the things that was most beneficial to me was really flexing and expanding the personal connections network that I had building in grad school and beyond. And again, like I kind of mentioned before, the sort of like cold email coffee date kind of thing. I think that's it was a very beneficial way for me to find out about where to look for jobs that might be interested, right? Like, oh, I found that so-and-so's job sounds really interesting, and they found their job on this particular, posting board or whatever. So now I'm going to go look there, right? And so I think that is a very useful thing when you're starting to kind of hone in on some career spaces that might be beneficial, to really kind of ask about where those people specifically found their jobs, because they can be quite different and quite challenging to know the right keywords to search through and that kind of stuff.
Yeah, I can speak following that as well. I think I totally agree, Juniper. It took so much time to look through job boards and the different locations and where you can even find these, these various types of jobs. But I totally agree. I think for my position now, it was just totally random. I happened to be on USA Jobs, saw a posting that was interesting and seemed relevant and kind of matched my some of my expertise. And so I ended up applying. But I think what really helped to get to that point was having a network and kind of speaking to a bunch of different people kind of throughout the government about how you kind of can best prepare yourself for USA Jobs, right? So speaking from the federal perspective here, but I think it was really helpful. I talked to, folks from EPA or USGS or, a whole bunch of different kind of sectors of the government to kind of figure out how to game the system's not the right word, but how to best kind of prepare your materials to be most successful on, for my case, USA Jobs. And I think that was really, really beneficial. So I think it's a kind of a combination of networking and just kind of blind luck, and being in the right time in the right place and really knowing where to look, like kind of Juniper was saying as well. A lot of time and effort for sure.
Yeah, I was gonna say, to me, that in finding the right kind of job, one of the key things was connections, as has been mentioned, but more than, there's various types of connections, but to me, like finding a mentor was absolutely crucial, one or several mentors. So to identify the kind of person that you could see yourself being in the future and the type of job they're doing was absolutely crucial for me. And then, befriend that person, make the effort, show that you would like to, work with them or find the kind of job that they have. Is really important, or at least was really important for me, because as you can imagine, just as when you interact with academics, people encourage you to stay in academia in a way. If you interact with non-academics, people will might encourage you to not stay in academia, or at least if they feel that that's your wish, they will support you in doing it. People want to work with awesome people, and so if you talk about your wishes to do something, people will try to encourage you to do it and support you. And so I've been forwarded job ads by people that wanted me to take up those jobs, you know what I mean? So that's another way of finding the right kind of role. And the other thing is that it doesn't have to be a drastic one step. It can be a few steps again. So as I mentioned, that could be a transitional job in between that's not fully outside of academia, but a little bit, and then you try something out and move to the next thing. So mentors, make sure that you make your wishes known and you're just generally engaged with people, and that can go a long way.
Gio, I have a follow-up question. When you say reaching out to mentors, are you thinking like cold emailing as well? In case you don't have those kinds of people in your circle that might look like mentors for you at that time.
I mean, cold emailing can work. I mean, one situation is this one, right? Where this is a situation where we could all be mentors here. I don't want to speak for everybody here, but if something that someone here resonates with you, a follow-up email might be useful, or a follow-up conversation, and then we can talk about it. And it doesn't necessarily lead to something immediately, but it's things that can pay off years down the line in weird and unexpected ways. And so just acting on some kind of feeling or impetus that you have to find out more, or show your intent, show your goodwill, can really go a long way sometime in the future. And sometimes it won't lead to anything at all, but if you don't ask, you don't get, I guess. Or if you don't act, you'll never know. Yeah.
I'm going to echo that, Gio, because that is exactly my story. Every little increment in my career path was done through finding a mentor that helped me get to the next step. And maybe it was just like a volunteer lab job that I did 2-3 times a week. But, they saw how passionate I was, saw how interested I was. And so the next time I applied to something else, they're like, yes, you've got to hire this person. They're great. And I do that now in my position. People will cold email me, like people I never heard of before, but they want my job, or they want to work at Bat Conservation International. And because that has been, my whole career path, I bend over backwards to help people get connected. I actually tell them, this is what I recommend you do. If this is where you want to be, these are the steps you should take. And if I see job postings, I forward them to those people. And especially in my discipline, it's very small. It's a small world. And who you know and who knows you takes you everywhere. So if you can, exactly as Gio was saying, imagine the position you want, seek out those people that you want to work with them, you want to be in their position one day, and then incrementally work your way there. And if you can show that, you are passionate, that like, this is, really what you want to do, people will help you. So that, yeah, absolutely true in my case.
To tack on another question that's related to this, another attendee asked, during your job search phase, what are some specific ways that you leveraged or translated your academic skill set into something that was more useful for your current position? And what kind of language or angles did you use to make interviewers understand your experience?
This is maybe a different take, but I have my job because I can make science accessible. And so at least for a public facing institution, when I got up and gave my job talk and didn't use the jargon, that's what made people like, oh, we're going to be able to talk to this person. Like, it seems like they know what they're doing, but I can understand it. And so for my organization, that was absolutely key. In other situations, I've been told I don't use enough jargon. It's worked out for me, but I would say that's the number one thing that has worked for me, is just saying things simply, and for my organization, a front-facing one, being clearly excited about what I do, because then that helps advance other areas of our mission, which include getting people excited about trees. So speaking simply and being accessible, I would say, is the number one thing that helped me along the way.
I can speak to at least some of the USA Jobs navigation stuff. Oftentimes in USA Jobs, there will be a specialized experience criteria in the job posting, and make sure that you are calling out those specific words in your resume and cover letter in your application material, because that's what HR is looking for when they're seeing if you're qualified or not. And so, if there is, a independent researcher or something, or independent thinking, maybe that's the language that is in the specialized experience of that job posting. Make sure that gets into your resume. And, if you're doing grad school, you have plenty of experience for, making that case. But, that's just one example. So make sure that you're looking at the job posting. It's going to be different for every job. But, this is kind of like the gaming of the system that Alex was talking about earlier. You first have to get past that HR step. And as for interviews, it's really going to depend on the job again. But, I think leveraging, all this independent work that you've done during grad school is going to be really key and valuable for a lot of different government jobs. I'm just speaking to government at the moment.
Yeah, I can echo that too. One thing that is a little bit different from my experience with USGS is that I did come on as a contractor first, and what ended up happening is I wrote a typical cover letter and did all of that and sent in an application and to the contractor company that was advertising this job. And then I also talked with the PI that was or the RG scientist that was going to supervise me. And what I ended up doing was trying to be very strategic about really telling them that I wanted to do applied science, because that's what USGS is all about. It's about delivering information for our partners and making sure that they have the science they need to make the decisions that they need to make. And so really focusing my passion is in applied science. And so it was really easy for me to say, I want to work somewhere where my science goes directly towards making these important decisions and influencing those in a way that helps the environment. And so that's what I did.
Does anyone else have anything to tag on to those paired questions?
I'll add on that one thing I've seen in my partner, who also has a PhD but no longer works in the field that they studied. They're now at a national lab. One thing that I think we both have seen being on the other side of the table now and when applying is one thing we've seen with grad students when they're applying for positions is if they keep talking about a very narrow field of interest, and unless the position is specifically saying, hey, I want somebody that can forecast water nitrogen in Lake Michigan or something like that, pitching your focus so narrow can make it hard to see how you'll fit in with the bigger picture. And so it's about, at least for the organizations my partner and I have applied for and work with, it's about being able to articulate kind of your broad expertise, but being careful about overemphasizing your dissertation research if you are not married to that being the only thing you ever research on. So being able to kind of articulate broader themes, the fundamental skill sets or what motivates that, but don't get over focused on my dissertation research is, because you hopefully won't be doing your dissertation research for the rest of your career.
I'll also add on that something that I didn't know back when I was a PhD student that I learned, and that was really helpful information for me. I had a number of friends that worked in industry in Silicon Valley, and I was really interested in data science at the time and breaking into a data science job. And what they told me is that you'd be really surprised who actually has those jobs that you want. You may see like the list of required or preferred skills. And what they told me is like, I sometimes have half of those skills, but if I can demonstrate that I, know adjacent skills and can learn on the job, that's often enough for me to get the job. And then you actually learn those skills that you need on the job. And for me, maybe coming as like a minority is like a person that suffers a lot from imposter syndrome, I would have never even thought to apply for a position that I wasn't 100% qualified for. Now in the position that I'm at, I'm on the hiring board for a lot of positions that come into our organization, and the top things we look for, general proficiency. Like, do they indicate that, maybe they don't know R, but they know Python? It's a translatable skill. But we want to know, are they thinking on a deep level? The cover letter matters a lot to us, how they articulate themselves, how they speak. And then because we're such a small organization, are you cool to work with? Is huge. We want to know that you're somebody who can work as a team member, who is a team player, who is somebody that we want to interact with and collaborate with. So even beyond skill set, those human personal skills go a long way.
Yeah, I totally agree with Tina. There's one thing that also frequently happens in, I guess we work in similar size kind of nonprofits. And it's, you're hired for a job, but you end up doing something else shortly afterwards. It's not, this is quite different from academia, where you're that faculty person that's going to be your job for a while. You might gain other roles, but essentially that's going to be your job. You're hired as part of the organization because you have a broad skill set, as part of a nonprofit, because you have a broad skill set, you're cool to work with, and you have these translatable skills that will make you useful eventually. At the beginning, you will probably have a job to do. As I was saying, we work a lot on project justified work. Once that project is over, there might not be that specific need or as highly as possible. There's also a higher turnover. Someone else comes in and the priorities shift. So you don't get fired at that point, but you might move roles. Like, people might realize that you're better used in a different way. So I don't know the participants we've got here today, but I would bet that you all have the skills necessary from the technical standpoint to get a job outside of academia in the types of environments that we work in. So it's really demonstrating how broad and transferable those skills are that is going to make you competitive, I would say.
So moving into more of like the daily type of questions, this is a few of you definitely already started to touch on this, but across these different career types, how do you all communicate model outputs with your other coworkers and also stakeholders, if you do communicate to stakeholders? So generally, what sort of information are you providing to the users, like journal articles, reports, parameters, management recommendations, dashboards?
Yes. So obviously, like, there's 1,000,001 research projects and 1,000,001 applied projects where somebody has a desired output and they want to know X, Y, or Z. And that's what you're tailoring things to give them. So, like right now I work with folks at University of Florida on the portal forecasting project, and we have journal articles on things. We've got a repeatable dashboard that's the website's automating itself, blah 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 blah. Similarly, actually differently, for a project that I can't tell you who the company is because NDAs and confidentiality clauses and stuff, but it's a company where they've got to do restoration, and it's a half-century timeline, and they're trying to do decision making about or they are doing decision making about sites for sampling, whether they go in the more intensive sampling or the less intensive sampling protocols. And they only have a certain amount of time and money to spend on sampling, and they need to figure out which sites to sample so that they'll get the best representation of sites for restoration over the next 50 years. And so that requires them to have forecasts of an ecological system and cost benefits into the future so that they can then make the decision now. And so, like with a lot of stuff, when you're trying to facilitate decision making, I like to refer to it as a car. I'm not a gearhead, but I want my car to work. When I put the key in and I turn it over, I want my car to start and I want to be able to get to where I'm going, right? I don't know how to change my oil. I mean, like, I know the idea of it, but I've never changed my own oil, right? Like, that's not my thing. A lot of people that I work with don't know how to change the oil of the model that I'm building, right? They want the output. They want to be able to go to the website, make the forecast and say, okay, given this, what should we sample? And so for this example of like site selection criteria and forecasting stuff, it's somebody who, you know, hasn't had a biology or math class since high school 30 years ago plus, and they need to make a decision right now. And so they push a button, it gets the data, it does the modeling, everything under the hood. A report is produced that then says, here's the decision that you should make. But then to support that, we have a report, we have, you know, we're working on manuscripts and stuff like that so that those things can be cited as part of the work that is the decision making for this federally funded large project, right? So there's a number of deliverables that support the same goal, sometimes with different people in mind as who the final output is for.
Speak a little bit on this. I am a big fan. What I do in my work is do co-creating of modeling processes with my partners. So we sit down often, used to be in person, now it's more virtual now. But we talk about the outputs that they need, what they think they need, what their goals are, what decisions they need to make. And then through an iterative process, we produce mock-ups. They can comment on those mock-ups. Then we go back and we refine the model based on that. And so we're together sort of going back and forth on what the outputs need to be and what the model needs to do in order for them to achieve their goals. And so I do a lot of that.
One thing we're doing with the drought forecasting that we're working on is really trying and talking with audiences and key partners is a skill, one that I am still working on developing, but doing a lot of thinking and talking with our key partners about, you know, what triggers a decision. And that helps us know what kind of information they're trying to act on. And then the next round is going to be, you know, what does that end product look like? And so a lot of it is trying to get in the head of the people we want to actually use our science, which I think lines up with, you know, what Laura was saying, also some of what Juniper is saying, but thinking a lot about what do you want to do differently and what do you currently base your decision making on, so we can either tie directly into that established framework or, okay, here's kind of a parallel thing, but it's not like making a U-turn or a complete 90-degree turn, but shifting the direction in small amounts.
One thing that I was going to say here is, in my personal experience, tools that enable you to translate your science into something interactive and easy to understand are absolutely crucial. So in my personal experience, I use tools like RShiny so much for our users out there. RShiny is incredible as far as I'm concerned because it allows someone that isn't a full stack developer and knows everything about JavaScript and everything else to translate your code and, you know, your understanding about statistics into a dashboard, an interactive web-based tool that can be easily consumed by someone that knows virtually nothing about all of it. And that's being absolutely crucial, even just to like get people on board with what you're doing, you know, because people are able to interact, see the products your work essentially. And so even if that's not the ultimate thing that you deliver, just showing progress in that kind of interactive way for me has been like key to get people on board with what I was doing. So I would encourage people, talking about skills, I would encourage people to really gain proficiency in those types of tools. Are Shiny, there's Dash if you work in Python, but they're really communication tools. And obviously, if you want to learn full stack development in JavaScript, that's really awesome. I mean, that would be even better. But I just wanted to say that about communication and skills, because I think that it's a really crucial part of at least my job, which may not be obvious otherwise.
Gio, you and I are on the same train, because that's exactly what I was going to say. In addition to publishing scientific papers, I almost always produce a Shiny app because we work with a lot of state managers and biologists that allow them to go in and interact with figures. We also collaborate with USGS on something called the BAT tool that forecasts population trends for bat populations. And people can actually go in and change the model parameters and see how it changes the output. So again, like what Gio said, they're really powerful tools. We also use our Shiny. It's really nice, easy, like you could literally take a template. You're like, oh, I want to create this Shiny app. And that's exactly how I learned Shiny. You look at the templates and the examples, and you can just reformat it to your purposes.
Sorry, one last thing here. I agree with what everybody has said so far. And one thing that's sticking out in my mind is when we interviewed a program manager at USGS a few months ago, he was saying that he was sick and tired of USGS doing almost useful science. And what he meant by that was that they would have a project and then write a journal article and then stop there, and not do things that Gio and Tina and Juniper and Laura and Christy all have said about, interacting with the people or the end users and making an Shiny app, or, talking about this co-production that Laura was talking about. And so really that's like key in a lot of non-academic jobs is, you're doing a service for somebody, whether it's a client or the public or Congress. And really it's kind of communicating that science to the end user is really key.
Yeah, and just to build off of that for a second, I think one of the really important softer skills that I find myself flexing a lot more in the space is active listening, and really thinking about how when you're in a collaboration space, it's not just about what you bring and what you want, but how you can meet what other people need, right? Even when you come from the same research background, but especially when you don't, the communication between the needs of the output and what you have and who you are might not be one-to-one. And so making sure that you can repeat back what somebody actually wants when you're having these conversations early on is really, really important. And so I would say, as much as you can, if you're in grad school now, like really figuring out ways to hone that as much as possible in collaboration spaces. And if you can take any kind of training in any sort of team building work around that, I think that gives you something a little bit more, certification or class or whatever, something that can often be more of a soft skill for folks. I think will help get you a leg up for sure. But any way that you can really practice not just hearing people from different backgrounds, but actively communicating and making sure that they understand that you understand them is a really, really important thing, and will definitely help you get kind of your name established in spaces where, are non-academic kind of thing.
Thanks. Moving from soft skills to hard skills, what do you wish you like hard quantitative skills did you wish you had known before starting your current position? And what was your journey in gaining those skills either before or after, like self-taught, university, attending like extra training outside of that? Or maybe I think someone mentioned earlier, maybe it was Jake, about just like learning on the job and people being nice to you about learning that.
Yeah, I'll take that as an invite to answer. I wish I had known Git a lot better. I mean, I use that every day, and we do collaborative coding. That's our bread and butter. And so knowing Git and version control is essential for our job. I would also say, related to that, having some sort of online presence of your coding skills is going to be really important for applying to data science type jobs. And that's just a really good way to demonstrate that you can do collaborative coding and you are actually a coder, without actually putting that in your resume. And in terms of like learning, if you don't have a skill going into the job, there's different ways, learning on the job, or, we do provide training opportunities, at least at USGS where I'm working, where we have dedicated hours to let staff train, and, a budget for, learning Python or some other tool that you want to learn.
Yeah, I think I'll just echo the on-the-job training. There's so many skills that I probably could have known to do my job, but the great thing about NOAA is that we do every year we have a performance plan that we have to develop, and as part of that, there's a technical skill that you have to learn, like some type of training, technical training that you do, and some type of soft skill training that you do. And so, I think that's been a kind of a nice surprise and a great benefit to the position, is that if I do have these gaps in my technical knowledge, I can fill them with external trainings, which has been really helpful. But otherwise, yeah, I mean, obviously having a really strong foundation in a coding language, a lot of what we do now is in Python, and so I wish I probably had more Python background than I did. A lot of what I did was in R and MATLAB. Yeah, having a strong background in statistics and modeling is always helpful, but a lot of it is on the job training and just kind of learning from the people around you as well.
One thing that hasn't been mentioned yet, or I agree with everything that's been said, but actually I'm going to say two things. The first one, talking about strictly technical computational skills, is cloud. Like the first word is cloud. Like everything, when you move to industry or outside of academia, or in academia for that matter, like everything's transitioning to the cloud. So your ability to navigate what happens in the cloud is essential. So I mean, like leveraging supercomputing facilities or optimizing things for the cloud. I mentioned, web development and things like that. So that's really a key set of skills that I certainly always try to learn more about. I wish I'd known a little bit more about it. The other thing, and this doesn't fit strictly in technical computational skills, but I think they are technical skills. And I'm going to mention like project management and people management, because like we learn almost none of that in academia, even as part of your PhD. And when you transition out, you find that that's a real key thing, like the ability to manage a set of deliverables in a timely way and manage a team of people to be able to deliver on those deliverables is absolutely key. And even if you have a very research focused job, it's likely to be a big part of your job. And also, I don't want to give the idea that, every job out there for members of the ecological forecasting initiative is going to be a highly technical job. If what you're interested in is that's great, but your understanding of ecological forecasting can be translated into a coordinator project management type job where you are managing those types of projects. And actually it's the other skills you have on the side that make you even more desirable. So yeah, think a lot about project management, people management. There's a whole courses you could take out there on it. And I'm highly inadequate about it, but people were okay with me as I was, thankfully, but it would definitely have been helpful.
I'm going to talk briefly about stats and comfort with stats, because that was like a big hole in my skill set going into my PhD, and it's like now all I do. I'm still on the learning curve, and I'm still learning different types of statistical approaches and being comfortable with it, even discovering holes in my foundational knowledge. So if I could go back to grad school, I would have maybe minored in stats, but without that, I will say that making up for it, what has helped is you can learn a certain amount in coursework, but until you actually apply those ideas and those methods to your own data, I never understood it and I never really got it. So actually getting in there and doing it with your own data makes a huge amount of difference. And the other thing that really helped me was simulating data, make up data so you can really understand, like, where does data come from? And where does that unexplained data come from? Where does that unexplained variation come from? And how do you account for that with different types of statistical models? So those types of things were really helpful for me. And I'm still learning, and yeah, and it's okay.
I think what Tina said just resonated with me, because I think that technical thing we wish we knew, it's going to change. You ask us even 5 years from now, it's like, well, crap, I never had training in XYZ. And so I think even more than having a particular technical skill, it's knowing how you learn and being able to identify what the next skill you need to learn is, because it's constantly going to change. And to be effective in any job, research, academia, whatever, you're going to have to be able to stay up to date and keep learning. And so the self-awareness of being able to identify those things and knowing how you learn best, whether you need to ask for formal training or whether diving in and tinkering is how you do it. But yeah, there's always going to be something that I wouldn't say necessarily you wish you'd learned, but it's like, oh, it would be really beneficial for me to learn this now, at the very least.
I'm sorry, I'm taking out so much. So I just want to piggyback real quick on what you said, Christy, because like another huge part of that is like facing your imposter syndrome. Like a little bit of us we all have a little bit of it. And until I could be okay with asking the dumb question and having people look at me like, oh, why did you ask that dumb question? I could never learn. So, fake it till you make it, find a support network, find that mentor who's, gonna be okay with you asking those dumb questions.
I think one thing, this isn't related to like a technical skill potentially, but it is involved in stats, and that is, as a non-academic scientist, what ends up happening a lot is partners will provide data to me and ask me to create some sort of tool or statistical process. And that data is incredibly messy, incredibly disorganized. And you spend a lot of time just trying to figure out what's going on with the data. And so being prepared to spend a lot of time just cleaning and organizing data, which I don't think is something that a lot of people in their grad school experience end up figuring out, just because you collect your own data, you know how it's organized, you know what you're doing with it. But figuring out how other people are organizing data, and it's often not collected in a way that facilitates the analysis that you want to do. is a really like problem solving skill that you have to develop. And so being prepared for that, I think, is really important, because I've seen some colleagues really get stressed out about that particular problem when they first encounter it.
100%. And to add on to that a little bit, I think, you know, in my job where I'm contracting out, or I'm getting contracted to do analysis and maybe don't have the support from whoever I'm working with to do the data munging, I, over the last, you know, decade or whatever, have gotten better and better at being very clear about what makes a data set shovel ready, in the way that I refer to it, right? Like if you're building a house, you don't want the people who are laying the foundation or who are digging the foundation to be there until the trees are cleared, right? Like there's a time and place for each skill set to be involved. And while academics, we like to learn new things and stretch our wings and all of those things, sorry for the rhyming, but whatever, we sometimes let ourselves get into mission creep of our own scope. And so like thinking about what will make it easier for you to focus on your work for a particular task can help you actually get the work done in a timely fashion. But it also really focuses your thinking about things into a pipeline. And I think that's something that, to harken back to the question from a little bit ago about like skill sets, really some of the like development of computational workflows and the ability to take an analysis that needs to be done every year and normally would take weeks or months every year to get done, and translate it into something that can get done automatically with maybe a couple hours of checking, right? Like the in order to get something, you know, workflow ready or, you know, machine learning ready as a data set, you need to be able to work with it as an individual first. And so there is that time of that translation. But then once that translation happens and the data are in a standardized format, then you can really get going, right? And so knowing that balance is really important. And it's one of those skills that if you can learn as a grad student to really think about like how to standardize data sets so that more data can be added and the analysis can continue to go, I think is a really important thing for figuring how to translate your work to you know, a new position.
Thanks everyone for that input. I just wanted to be mindful of the panelists' time, that it is 2 p.m. So if you have something that you need to go to your next Zoom meeting, feel free to drop off. Thank you so much to everyone for coming today and giving your expert opinions and input for these things. I know that I've definitely learned a lot today. And I feel pretty confident speaking for the rest of the attendees that there's a lot of good information here. For those of you that wanted to stay another minute, I think a closing question, well, we got a question from the registrants that I thought was interesting to close out on, which is, do you think that ecological forecasting is an academic fad? And if not, where do you see it being most beneficial in your type of position in the next 10 years or so?
I'm sorry to do this, but I have to run soon. First of all, I wanted to say thanks so much. This has been awesome. I'm super happy to have met everyone here. I think this was a really, really great discussion. I just wanted to say one thing on imposter syndrome really quickly. I'm sorry to go back to the previous question, but we all experience it. No doubt about it. We will continue to experience it. You're always in new situations which you're somewhat not super well prepared to deal with at times, and that's just the way it is. But what I wanted to say is it's key to listen to your imposter syndrome. Like, it can get out of balance. You can be in situations where your imposter syndrome is suggesting that that's probably the situation where you shouldn't be, or you're not as comfortable being. So think about the situations you're in, your day-to-day different tasks and things, and think about where you feel like you're less of an imposter, or you feel more comfortable hanging out in that space. And that can really be a key thing for you to understand where you want to go as you weigh your different options. So I just wanted to say we all experience it, and that's totally fine. And I don't want to minimize that at all, but it can be out of balance, and it can be an indication that you maybe want to move to a different kind of space in weighing your different options here. So thanks so much, everybody. Yes, ecological forecasting is absolutely key out there. And I'll just say one thing. I heard earlier today that, you know, outside of academia is actually further along than academia. I don't disagree, depending on what you're talking about. But as far as I'm talking, in my environment, ecological forecasting, we're probably 10, 15 years behind as far as the nonprofit environment is concerned, and what federal agencies actually consume. I don't want to talk for USGS, but a lot of federal agencies actually consume on the ground. And so in 50 years, we're only going to be 35 years worth of academia along, if you think about that from my perspective anyways. So I think it's totally an absolutely crucial field to be in. And climate change, we don't know how to do it, but everyone wants to know it. So if you can figure it out, that's great. Anyway, thanks so much, everybody, and take care. Thanks for having me.
Yeah, first and foremost, just want to respect panelists' time, so feel free to drop off. I think that there's, instead of answering my last question, I think there's a couple questions. Anyone who has their hand raised, if you just want to pop it in the Q&A or the chat, that would probably be the easiest way.
I will say on the forecasting as a fad question, I had to chuckle because when I interviewed for my job, one of the older staff members here asked me what I was going to do when this climate change fad passed, which was interesting. But as somebody who'd been in his field for over 30 years and had seen like nitrification be a big thing, that was like the top issue, and then it kind of waned. Kind of understood where he was coming from, but I think at the core of it, it's thinking about kind of what are the foundational skills. So, you know, ecological forecasting as a tool, I think will just kind of become a part of the standard work box. But I think there's a lot of kind of foundational ways of thinking and working that are going to keep going. So maybe ecological forecasting is eventually going to go down in its occurrence in funding calls and things like that. But I think a lot of the ideas and concepts are kind of fundamental, and it's going to shift how science is done and how science interacts with other fields. That's one of my little soapboxes.
I'd agree with Christy. Like at its basic level, like decisions are about the future, and ecological forecasts are a tool to help make those decisions. So I don't see it like going away or being a fad. And also for USGS, there is ecological forecasting that is going to be funded for, you know, maybe a decade or so. And so it's like, yeah, it's here to stay.
Yeah, I absolutely agree. And putting on my NOAA hat, you know, NOAA likes to talk about the new blue economy, which is this idea, right, that you can use data and models and forecasts to generate like a whole nother sector of the economy. And, you know, that's something that I think they're really behind, and I don't see that changing, right? I think one of the examples that's been told to me is, we have weather forecasts, so why can't we have ocean forecasts that are privatized as well, right? It's the same idea, like with HAB forecasts, that's vital information that folks can use to protect their health, to protect their, the shell fisheries or the fisheries or their property. And so, kind of going with that model, I think it's certainly here to stay.
Any other closing thoughts?
Yeah, just to say thanks for the really interesting and awesome perspectives of folks from some different backgrounds and different experiences. And yeah, no, forecasting is really important in and of itself as a out of sample prediction evaluation exercise. And so whether you think about forecasting as a temporal thing into the future, or you think about out of sample spatial forecasting or whatever, when rigorous out of sample forecasting steps into a field in the way that it has with ecology now, in the way that it did with econ, in the way that it did with climatology and weather, it's not something that's going to fade as a foundational tool. However, there are fads around funding, and that is a real thing. And some of the funding things that happen right now, like nitrification, is still really important, right? Like biogeochemical cycling is still really important to understand, right? Like nutrient stoichiometry is fundamental. However, if you write a call on eutrophication as opposed to forecasting the impacts of changing nitrogen cycles, right? Like it's just like there are fads around funding, there are fads around job postings, and those are important to know because those are the keywords that people use, and those are the ways that you highlight your skills, right? So while I think there is a fad aspect to it, that there's a strike while the iron is hot, certainly for a lot of the folks in this space, if you're looking to, as you're leaving grad school to go into a workforce and do forecasting, like you're getting trained in the terminology in the space of thinking about it, particularly right now, that is very beneficial. That might not be directly so in a decade or 2 decades, but the skills are still going to be very important. And so I do think there's something important to call out there in terms of that fad aspect when it comes to funding or job calls, but the fundamental skills are going to be important well beyond.
I think that's absolutely true, and publishing as well. A lot of journals only accept novel things, and so exactly as you're saying, Juniper, if you just spin the way that you look at it or the way you phrase it, and you put forecasting in there, it could be more likely to get published. And there are definitely fads with publishing.
Awesome. Thank you all so much for coming today. And I really appreciate it and giving your expertise. And for those of you that are attending today, I will be sending out this recording. Give it to the email that you gave when you registered. And if you have any more questions, feel free to email me and I can pass you on to the appropriate people. So yeah, thanks so much, everyone.